Hey everyone, Brandon here. So this is kind of something new for me, so just bear with me. I'm trying out some new software to capture this, and just gonna try a new video format. If you saw one of my most recent videos, I took some time to build a sled for my bandsaw, with the idea of being able to take large logs that I had just a whole pile of, several piles actually, uh, taking those, which would otherwise be used for firewood or, left to rot somewhere in the woods, um, not very large in diameter, so not completely, I don't know what you want to say, not useless, but not ideal. Like, you're not going to get much usable wood out of there. So to take logs like that, build a sled for the bandsaw so that I can take these kind of larger, cumbersome logs and mill them into boards on the bandsaw. Now, with a lot of my projects around the house, money is something I take into consideration. Um, we have two boys, we have a camper, we like to travel, we like to go on vacation. I like to spend my money on those things and not necessarily on like new big shiny toys in the workshop that aren't always going to get a whole lot of use. So the idea was to build this table for this purpose of milling these 5 foot long, 12-inch diameter logs into usable lumber, but not spend a ton of money. So right off the bat, linear rails out, things like that. And the one benefit I do have is that I have a 3D printer. So I like to incorporate the 3D printer into a lot of my projects. And if you watched the last video, you'd see I made these brackets for the bottom of the sled that goes on the bandsaw, that I can attach these ball bearings to. These are just skateboard bearings I got off of Amazon. They're relatively inexpensive. But I was able to 3D print a part, and with these bearings, a couple nuts and bolts, I was able to make a bandsaw sled that rides along actually electrical conduit, which, for the purposes of just roughly milling up a log, it doesn't have to be dead on accurate, so again, the linear rail's not really necessary, and I gotta say it works pretty well. I'm very happy with it. That being said, there's been at least one comment on the video, which makes a good point. Is this the safest it can be? And the short answer is no. No. There's always ways to improve things to make them more efficient, to make them safer. And this commenter had a very good point. When you're pushing that sled, you don't have to put like really any force on it. It runs very smoothly. But say you get like kind of a bind, or like the part you're cutting is pinching the blade a little, and you go to put a little more force in. Well, you're standing to the left of the blade as you're facing it. The sled is sitting to the right of the blade. So if you're pushing that sled, your arms are crossing in front of the path of the blade. You should never run into a situation where you're putting your entire body weight into it, where if there were an accident and you slipped and fell, now you're in the blade, and that's a bad time. You should never run into that situation. That's just, I think, general tool use. You should be knowledgeable enough to use that tool, and knowledgeable enough to know that if you have to push something that hard to cut it on a high-powered piece of equipment like that, you should probably stop and reevaluate the situation. Now, that being said, I'm looking into ways, and I mentioned in the comments on that video, I'm looking into ways to make this safer. And one of the things I want to do is have a rack and pinion system that all I have to do is load up the log get it clamped down into place, get it positioned to where I want to cut it, and then basically just have a big turn wheel that I can turn, and that's automatically going to feed the sled into the saw. That's not to say I can't upgrade it down the road and maybe motorize it so I don't have to sit there and crank this turn wheel, but regardless, just kind of thinking of ways to make this easier. And that got me thinking, and the reason I'm doing this video, and if you're still with me, thank you for hanging out this long. The whole reason for doing this video is I need to 3D print, I need to design and 3D print a couple parts to make this happen. And rather than just showing you the 3D printed part I've designed off camera and printed off camera, I want to show you how I'm going to design it. So there's really 3 things you need to do this. One, you'll want any parts you'll need. So in this instance, the part I need to design is a pillow block, basically, which is basically a ball bearing mounted in a block. And that block can be mounted to a surface. I will need at least 2 of them, basically to mount the hand wheel, the axle of that, across underneath that sled. And I will need 2 points, 2 pillow blocks, where that axle can thread through to support the axle. So the 3 things I need are my ball bearing. I need my calipers to measure said ball bearing. And I will also need software to model this. The software I like to use is called Fusion 360. If you're familiar with it, great. If not, there are a ton of YouTube videos out there that can teach you how to use it. I used SketchUp for a long time before this. I've recently, in the past year or 2, moved over to Fusion. And it's a little more of a learning curve, but it is a much more powerful tool. You can get much more complex shapes. You can do all kinds of really cool stuff with it. It's available for free for personal use, and that's how I use it. And if it's something you're interested in, you should definitely check it out. So here, let's see if this works. Oh, look at that. Here is the Fusion 360 desktop. So, like I said, I'm going to get started. I'm going to design this pillow block and show you how I do it along the way, and we'll see how this goes. So first, I just want to get some measurements to remember. These ball bearings should be 22 millimeters wide, and I know I'm kind of doing it off camera, but it's kind of hard to show you, but it's 22 millimeters in outer diameter. The thickness of the bearing is 7 millimeters, and I believe the inside diameter is 8. It's a pretty standard size. Yep, 8 millimeters. So everything in millimeters, and if you're familiar with 3D printing, it just kind of translates better that way if you set up everything in millimeters. And that way you don't have to worry about scaling. So we'll get started here, and one of the first things I like to do that I recently learned is setting some global parameters. So, like I said in the beginning of the video, I've not really used the software before, and it shows. I went to edit the video this morning, and you could see Fusion 360 in the video, but any of the pop-up windows where I would enter my parameters, things like that, didn't actually show up. I had my settings wrong. So I'm going to re-record everything. We're going to pretend that I didn't finish the print of the pillow block, and I'm going to run you through it, and we're going to recreate what I did initially to show you how to do this. So let's bring up Fusion here. Ignore that. Here we go. So here's our pillow block, and we're going to go through and we're going to basically just replicate everything here, to show you how to do it. So let's hide this. We don't want to see this. Actually, let's just hide that one because we want to see the one we're about to work on. How I start things typically is I go to Modify, Change Parameters. Now, I already have these built in here, but if you want to add a new parameter, you can hit the plus sign, put in your parameters name there, and then whatever units you can see. It depends on what you're working on. There's angles, there's currency, there's all kinds of stuff. I typically just work in millimeters. You can put in the current unit and then hit OK. You can see in here, here are the parameters I set for this design. The bearing outer diameter, the bearing inner diameter, the thickness of the bearing, and then the tolerance. So the tolerance is based off of my 3D printer's capabilities. I know just from having used the printer for several years now that I need to give things about a 0.2 millimeter tolerance to make sure I get a nice snug fit. Specifically, in this instance, the bearing that's going in the middle of this pillow block. If I don't have that tolerance built in, the parts tend to be too tight and you can't really get that bearing in. With a 0.2 millimeter tolerance, it fits in nice and snug. It's not going to come out, but it's not impossible to get in. This is something, it can vary from printer to printer, and it's something you have to play around with your prints and just experiment for yourself. There are tolerance testing prints you can do on the 3D printer to get an idea of what tolerance you want. But for me, it's going to be 0.2 millimeters, and it's built in as a parameter. So the outer diameter of the bearing, the inner diameter where our axle is going to pass through, and the overall thickness of that bearing. So we'll hit OK. Now we're going to start our sketch. We'll go over here to Create Sketch. We're going to pick this plane here. We are going to start with our center circle where the axle will pass through. Let me zoom in there a little so you can see it. And instead of putting in 8 millimeters, which is the diameter of the inner of that bearing, the inner diameter, we're going to do bearing OD. Where's my cap locks on? Okay, so bearing, bearing ID. We want the inner diameter. My mistake. Now we also don't want the back end of the print to touch the axle, so we'll add +2, and that will make it, you can see here, 10 millimeters in diameter. And if you remember, that all maths out because our inner diameter here is 8 millimeters. So 8 + 2 is still 10. Now if I take this, just to show you how the parameters work, say I make a bunch of different slots where this measurement comes into play, and oh no, I miscalculated and the inner diameter is actually 15 millimeters. I can just come in here. Instead of going to the drawing itself, I can come right in here, change that to 15, hit enter, and you can see our circle diameter has just increased to 17. So it's still the bearing inner diameter, which is now 15 + 2. This really saves a lot of time if you get a pretty complex design where you have multiple instances of the same dimension, and rather than having to go through everything, like I said earlier, you can just update it once here and it will automatically update your entire sketch. So we have our inner diameter circle. We'll hit C for circle. We'll do our outer diameter circle, so bearing OD. And this is where the actual bearing is going to go in, so we want the outer diameter plus our tolerance. Hit enter. So you can see there it is 22.20 millimeters. Perfect. It's our outer diameter plus our tolerance. Now, I need to do the outer wall of all this. So we'll do another circle, and we'll do bearing OD, outer diameter, and I want to have about a 5mm thick wall on either side. So bearing OD plus 10mm. There we go. Beautiful. We're also going to draw a line. I'm going to draw one down the center, and you'll see why in just a minute. Hit the select tool, select that line, hit X, because that's just a reference line. It's not going to be part of our actual design. Hit the line tool again, and we're going to come out from here. What is that, 16? And I want to come out another inch out this way. So 16 plus 25mm roughly for an inch, doesn't have to be exact, is what, 41. So 41mm, enter. And we are also going to select that, hit X. Out here, we're going to do another circle. We'll make this 10mm. And we need to have screw holes, as you can see in the final design. We have holes on either end for our screws to mount our pillow block. We don't want to put them in the center of the circle because they're too close to the edge, and I'd worry about, them cracking and breaking over time. It's a thin little bit of plastic. So we're going to go right here where this line intersects the circle we just made. And these are going to be 6mm. That's going to give us plenty of clearance for a screw, maybe a small bolt, so that the threads aren't catching on the plastic. And in my experience, depending on what type of screw you're using, if that catches on the plastic, it tends to separate the layer lines of your print. They don't really cut through it very well. So there's our screw hole. We can trim this out because we don't need that part of the circle. Actually, let's wait. Let's wait on that for a minute. We'll get to that in a second. So we're going to go back to our line tool, click anywhere on this big circle. If you go over here to the bigger circle, you'll see there a little circle shows up, and that tells you that the line you just made is tangential to the big circle here. So we'll click there, and if you're paying attention, you'll probably notice that it is not tangential to the small circle. Well, we will take the tangent tool up here in constraints, click on the line, click on the circle, now it's tangential. We'll do the same thing for the bottom one. Boom, there you go. Now we can use our trimming tool, because we don't need this, or this, or this, or this. Don't need those. Trim all that extra out. It doesn't really matter if you don't, you just have to be a little careful when you extrude some things later. I'm sorry, my calendar alerts are coming up. I should have disabled those. So now we want a mirror tool because we want another flange over on this side. So we will select our objects. You can see in the little window here, objects, 2, 3, 4 parts of our flange. And our mirror line is going to be this line that we put in the center earlier. And now you can see it's showing us where that is going to show up. Right over here where we want it. Perfect. We hit OK. And now we have a perfect mirror image of our flange. So we'll go ahead and finish our sketch. You can see now we have a flat sketch. We want to extrude this tool here, where you can just hit E. We'll extrude the flanges first. We want them to be pretty robust so that, it's plenty strong. So we'll go ahead and make that a 5mm extrusion. Hit OK, enter. And now you see we have the flange, but our centerpiece is not there. So let's go down here to sketches, This is sketch 2. Just because I have the original sketch in from the video that didn't work out. If you're following along and you started from scratch, it'll be sketch 1 for you. So now you can see, if you unhide it, you can see our original sketch. We'll again hit the extrude tool. We don't want to extrude the centerpiece because that's going to be open for our axle to pass through. We do want to extrude this, and this is what our bearing is going to be pushed down against in the finished print. And we'll make that 3 millimeters. There shouldn't be really any forces playing on this. 3 should be plenty. Hit enter. That was bizarre, but okay. Everything looks all right. Okay, so now we need to extrude this section here, so we can hit E for extrude. Select here. Now we want it to be 3 millimeters, the same as this part, but we also need the depth to cover the entire width of the bearing. So 3 plus bearing thickness, like that, and then plus we'll add the tolerance just to make sure that the bearing is not protruding out the top of our print. Okay, go ahead and hit enter. And now the sketch that we were using is kind of in the way. Kind of looks a little weird. There we go. So we can get rid of that sketch, hide that. And now we roughly have the shape of our pillow block. We'll add a chamfer right here under your modify tools on the inside, and we'll do it should be more than 0.2. Let's do 1 millimeter. No, that's too much. We'll do 0.5, I think is what we did last time. We'll give us a little bit of a chamfer just to dull the edge a little and make it a little easier to guide that bearing in. And now on the outside, do chamfer again. We'll select this edge here, this edge here, and I think we'll do 5 millimeters, 5.2. Yeah, 5.2. If you do the math, that will take you right to the top of this edge. And that gives us a nice clean look, a nice gentle taper, which should give us a stronger edge here. Again, it's like a light to medium duty pillow block. You know, we're not going to be parking a truck on top of this thing. This should be plenty. So we go ahead and hit enter. And there you have it. Now let's see. Let me pull up the other one and see how close we got. Oh, that's probably why it flipped out earlier. Let's move this. Just grab the move tool. No, we'll move it this way so they're nice and side by side. Okay, 35 millimeters should be enough. And now we'll unhide body 1 and look at that. They are perfectly identical. Wonderful. So there you have it. Now we can take this and we can export it. We'll hide body 1 again. Take it and we will go up here to File. We'll want to save first. Hit OK, user saved. And now that our file is saved, we can go here to export. And yep, we versioned up since I revised this. We will want to save it as type STEP, step file. If you're familiar with 3D printing, the STL file is probably your most common format. I've started using the step files recently because it retains a little bit more of the original quality of your design. It doesn't turn everything into polygons. You know, get nice rounder shapes. It's supposed to be a cleaner print. I haven't noticed too much of a difference, maybe a little, but it works. It's a bigger file size than an STL. It's really not a concern. I just prefer it. But, you know, if you're hooked on STLs, STL's just fine. I'm going to use a STEP. Click that. Here's where I'm going to export it. Hit export. Now, if I go, ignore that, 3D printing file, workshop, bandsaw sled, and if I go to date modified, right here is pillow block V2. There it is. That is the file we're going to take and we're going to load into our slicer. I've already filmed that, so I'm not going to repeat it, so just stay tuned to see how that all works. Alright, so that's pretty much it as far as the 3D design for the pillow block goes. I can now throw it into my slicer and get that file sliced up. If you're not familiar, the slicer takes your 3D design file and converts it into basically a format that the 3D printer can read. If you just put that step file on your printer, nothing's going to happen. You need to convert it into code that the 3D printer can read. It basically tells it, here's how to print this design layer by layer. So we'll do that next and just show you what settings I use to print some of these parts. And we'll go from there. Okay, so I have my slicer software loaded up. Let me show you that. So this is Orca Slicer. I've been trying it out. I like it quite a bit, actually. It's pretty nice. But some other popular ones are Prusa Slicer, Cura. If you're familiar with 3D printing, you've probably heard of these programs. I've been trying out Orca Slicer. A lot of people online seem to really enjoy it. And it's worked very well for me. Just even the default settings for a lot of filaments, a lot of printers have been much better than some of the other slicers I've used in the past. But just to give you a quick rundown, we're going to add our model here. Let's see. And it is, let me see if I can find it. I have a lot of stuff in this folder. This project has been going on for a very long time. So we'll load the pillow block, and you can see there it is. Look at it. It's so cool. I'm going to need at least 2 of these. So you can right click and hit clone, and number of copies 1, hit OK. And now we have 2 of them, and they're right up against each other. So we will hit this button, which is arrange all objects, hit arrange, and it will put them in a spot on your print bed that makes sense to the slicer. And 9 times out of 10, it's just fine. You don't really have to monkey around with it. It'll work just fine. You don't want them to be too far apart on the bed, because then it just adds time that the print head has to move back and forth between the 2 parts. If you have them too close, you can run into issues with like probably stringing or, you know, who knows. But this looks just fine. So as far as our settings go, yeah, I usually print at a 0.2 millimeter layer height. I'm using a 0.4 millimeter nozzle, which is pretty standard. There's a lot of information over strength regarding your layer height. Thicker layer heights lead to less layer lines, less layers, and where your layers actually come together is your weakest point in a print. So the less of those you have, theoretically, the stronger the print. A bigger nozzle can also make it faster and give you thicker layers, which can also increase the strength of the print. This is going to be a pretty light to medium load. I'm not too worried about it, and I'm not going to switch out my nozzle just for this. So all that being said, we're going to go with a 0.2 millimeter layer height. I don't really mess around with a whole lot of these settings. Under here, these are all the advanced settings, and like I said, Orca Slicer, the default settings are pretty close. The only things I really mess around with would be the layer height. I like to do 3 wall loops so that you don't really see the infill, the inside of the print from the outside. The less you have, the thinner the walls are going to be. And if you're not familiar with a lot of this terminology, I apologize. Infill is the inside. You can make the print completely hollow if you want, or completely solid. There's pros and cons to those, and usually it's best to do a percentage of infill where it's not completely hollow, it's not completely solid, but some of it is filled in, and that will add strength and rigidity to your print without adding a lot of extra material and a lot of extra printing time. So I like to do 3 wall loops minimum. I'm going to knock the top layers down to 5. I don't think we really need 7. Our infill density for these prints, since they are going to be holding a little bit of weight, there's going to be some forces on them. I usually do no less than 30. I'll do 50 for these. They're not very big parts. I don't think it's going to add a lot of print time. And we're going to do cubic infill, which I just kind of like the look of it, and it is a very strong, durable infill type. This is just going to impact the shape that the infill prints in. And there's a whole lot of options to choose from. But I've been doing cubic lately with a lot of success, so I'm going to go with that. Speed, I don't really mess with. I have an Ender 3 Pro. It goes about as fast as it can with the default Orca Slicer settings. I'm happy with it. It's okay. Not going to mess with that too much. Support. We don't have any overhangs, which is good, so we don't need our supports turned on. I'm not going to do a raft for this because it's a pretty big, broad piece. A raft is where it will just put down a couple layers of plastic before it starts your print. Your print will print on top of that, and that can help with if you have bed leveling issues or a print that only has a small point of contact on the bed. You can put a big raft down and then stick your print on top of it so your print doesn't come loose while it's printing. But we don't need a raft here. We don't need supports here. I don't think we really need anything in here. We're not getting into the advanced settings. We'll do bed skirt. We don't really need a skirt. Just turn that down to 0, but I do want a brim, and that will print lines around the print, which just helps with adhesion to the print bed, and it will help give you nice, crisp, clean, straight lines. So we'll do auto, and we don't need a gap. And I think, no, we'll do outer brim only because I think auto, it's just not going to give us a brim. And we'll do a brim width of 2 millimeters. I don't think we need much, but I just like to have them there as some insurance. That's about it. So now we have all our settings. We can go ahead up here and click Slice Plate. And now this is converting our design to G code, which is the code that the 3D printer will read. You can see here what it's going to look like. Gives you a ton of information. Basically, and I don't know, my head's probably in the way down there in the corner of the screen, but right in here, it's going to tell us we're going to use about 21 grams of filament, which isn't bad. It's nothing. Based on the cost of the filament, that's about 50 cents worth of material. And it's going to take a total of 1 hour and 51 minutes to print these 2 pillow blocks. So, if you think about it, I was talking at the beginning of the video about cost savings. We now have 50 cents worth of material 2 of these bearings. I don't even know what they cost. They're like, I want to say like $1 a piece. So I just got 2 pillow blocks for what, $1.25 a piece. That, you know, I'm not building some crazy complex piece of machinery. For what I need for this light duty use, it's just meant to hold this axle so I can turn this hand wheel. Do I need to go to Granger and buy like a $50 pillow block? No, this is going to work perfectly. Just takes a couple minutes to design. It's going to take a couple hours to print. You pop it all together and you're good to go. Don't have to run to the store. Don't got to get in the truck. It's wonderful. With that being said, we've sliced it. Oh, and you can also like go through and see line by line how the printer's going to print this. So pretty cool stuff. Now I just need to export it. So we're going to save this file now. And it's going to go right in my G-code folder here. I'll hit save. And now I can take that, load it on the printer, and in a couple hours I'm going to have these in my hand. At this point, I'm going to close this down. I'm going to get all that loaded on the printer, and I will be back with some 3D printed parts. All right. It is the following day. If you couldn't tell, new shirt, clean hair. Let the prints go overnight. They wrapped up, and I pulled them off this morning, and you can see, check that out. Got 2 of them actually. See, right there. Isn't that sweet? Look at that. Again, they only took like 2 hours, but you know, I had to get to pick the kids up and, you know, make dinner and all that. So anyway, got 2 pillow blocks. Let's check our bearings here. Get 2 of these guys out. See how well we did on the fit. So, bearing, pillow block. See if I can get this on camera. Look at that. Whoa. Ah, so satisfying. So, they sit a little proud. That tolerance was off. Probably could have added 1 or 2 millimeters instead of the tolerance. Is it a big deal? Not really. We'll give it a try and, you know, see how it goes. But, oh, never mind. Look at that. Just had to push a little further, and they are sitting nice and flush. Ah, beautiful. I spoke too soon. That's nice. Let's try the other one. Oh. Give this a shot. Let's see if I can get it right, and love it. Just snap right into place, and they are in there, and they are not coming out. So I have a little bit of stringing on the inside, but I don't know if you can see it. Might be hard to see, but you can see the internal diameter of the bearing is smaller than the actual pillow block, so we shouldn't have any issues with the axle rubbing on there, you know, causing some premature wear. Look at that. Fantastic. Alright, well, that's about it for this video. I hope you enjoyed it. Again, first time trying out something like this, so see how it turns out post-production. I got some editing to do now. If you liked the video, let me know in the comments. If you didn't like the video, also let me know in the comments, but try to be nice, maybe. And if you have any ideas for anything else you want to see in the future, if you like this video, let me know. There are other parts I still need to design. There are parts I have designed that I could go over how to design. The next video I want to do, I still need to make the rack and pinion gear for this hand wheel. So I'll show you in the next video how to do that in Fusion. We'll get that printed and then we'll install it on the sled. But yeah, if there's anything else you want to see, just let me know. And thanks for watching. We'll see you next time.